Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equations. So let's get going. Problem. Solve d square plus 2 into y equals to x square e power 3x plus e power x cos 2x. Firstly, let's find order and degree of the given differential equation. Identify the highest derivative here. D square is the highest derivative, so order will be 2. And highest power of the highest derivative is a degree. Degree is 1. Or just write the given differential equation as d square y plus 2y equals to x square e power 3x plus e power x into cos 2x. We know that d is a differential operator. Then d square will be, right? Now let's write the given differential equation as d square y by dx square plus 2y equals to x square e power 3x plus e power x cos 2x. Here d square y by dx square is the highest derivative, so order will be 2. And highest power of the highest derivatives are degree. Degree is 1. Now coming to the problem. Given differential equation, d square plus 2 into y equals to x square e power 3x plus e power x into cos 2x, which is an operator form. F of d into y equals to q, where f of d equals to d square plus 2 and q equals to x square e power 3x plus e power x cos 2x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function, yp is a particular integral. We'll find complementary function using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by putting RHS to 0, we'll get f of d into y equals to 0, which is a homogeneous equation of the given non-homogeneous equation. And we'll find yp using 1 by f of d into q. So firstly, let's find yc and yp. We know that the auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d square plus 2. Let's replace a differential operator by m, so that we'll get f of m equals to m square plus 2. Then our auxiliary equation becomes m square plus 2 equals to 0. Then m square equals to minus 2. Then m equals to plus or minus square root of minus 2. Now split this square root of minus 2 as minus 1 into 2. Then m equals to plus or minus square root of minus 1 into square root of 2. We know that square root of minus 1 is I. So we'll get plus or minus I root 2. Therefore, m equals to plus or minus I root 2 are the roots of our auxiliary equation, right? Which is a pair of complex conjugate roots, right? Here we don't have real part, so we can call it as purely imaginary roots. Okay, pair of purely imaginary roots, we can say. If A plus IB is a complex number, then its conjugate is A minus IB. If A minus IB is a complex number, then its conjugate is A plus IB, right? So we can call A plus or minus IB as a pair of complex conjugate roots. When M equals to A plus or minus IB, then our complementary solution will be e power ax into C1 cos Bx plus C2 sin Bx, right? In case of A0, we'll get e power 0 into x, which is e power 0 again. E power 0 is 1, so we'll get 1 into C1 cos Bx plus C2 sin Bx, which is C1 cos Bx plus C2 sin Bx. Right? Now let's write complementary function to our problem. yc equals to 4b equals to root 2, will get C1 cos root 2 into x plus C2 sin root 2 into x. That is y equals to C1 cos x root 2 plus C2 sin x root 2. We got yc. Now let's find particular integral. Particular integral. We'll find particular integral using 1 by f of d into q. We have f of d and q, where f of d is d square plus 2 and q is x square e power 3x plus e power x cos 2x. Right? This is equals to 1 by d square plus 2 into x square e power 3x plus 1 by d square plus 2 into e power x cos 2x. Now let's find each term separately. I'll start with the first term. 1 by d square plus 2 into x square e power x. So this is of 1 by some function of d into e power ax into some v form. Right? Now we'll shift e power ax towards left by replacing d with d plus a, and later we'll operate b with 1 by f of d plus a. So let's compare e power 3x with e power ax. Then for a equals to 3, we'll find d plus a is equals to d plus 3. Right? Now let's shift e power 3x towards left by replacing d with d plus 3. We'll get d plus 3 whole square plus 2 into x square, which is equals to e power 3x into 1 by d square plus 3 square is 9 plus 2 3 is 6d plus 2 into x square, which is equals to e power 3x into 1 by d square plus 6d plus 9 plus 2 is 11 into x square. So the denominator is of descending order. Let's take the lowest degree term 11 common from all the three terms. But in the first two terms we don't have any 11. So what we'll do, we'll just multiply and divide 11 to the first two terms. Okay? Just multiply and divide 11 to these two terms. So that in the next step, it will be easy to take 11 common from these two terms. Then this becomes e power 3x into 1 by, take 11 common, we'll get 11 times d square plus 6d by 11 plus 1 into x square is equals to e power 3x into, now split this fraction as 1 by 11 into 1 by d square plus 6d plus 11 plus 1 into x square. This becomes e power 3x into 1 by 11 is e power 3x by 11 into 1 by, I'll write this denominator as 1 plus d square plus 6d by 11 into x square. So this fraction is of 1 by 1 plus x form, so we can write it as 1 plus x whole inverse. We'll get e power 3x by 11 into 1 plus d square plus 6d by 11 whole inverse into x square. Now we need to use binomial series expansion. 1 plus x whole inverse equals to 1 minus x plus x square minus x cube plus so on. But here we are having x square. So let's find derivatives of x square. See here, we are going to use, here you are having x square, right? Here the number is 2. So we'll get derivative still d square. Okay. That is, we'll get the values for derivative of x and d square of x. From d cube of x, d power 4 of x, you will get the values 0. We'll see this now. Let's find the derivatives of x square. Derivative of x square is 2x. D square of x square is derivative of d square of x square is derivative of x square. We have the value of derivative of x square, which is 2x is equals to 2 into derivative of x is equals to 2 into derivative of x with respect to x is 1, which is equals to 2 into 1, 2. Right? Now, d cube of x square is derivative of d square of x square. We have the value of d square of x square, which is 2, and we know that derivative of constant is 0. Right? As I said you earlier, derivatives of x square from d cube becomes 0. Likewise, d power 4 x square equals to 0 and so on. In general, d power k of x square equals to 0 for k equals to 3, 4 and so on. Right? Now, keeping this in mind, we'll expand this using 1 plus x whole inverse expansion, 1 minus x plus x square minus x cube plus so on. So let's expand 1 plus d square plus 6d by 11 whole inverse using this series. 1 minus d square plus 6d by 11, just compare 1 plus x with 1 plus d square plus 6d by 11. Then for x equals to d square plus 6d by 11, we'll expand this. Okay, we'll get 1 minus x plus x square, that is d square plus 6d by 11 whole square, okay, minus cube plus so on is equals to 1 minus d square plus 6d by 11 plus expansion of d square plus 6d whole square is d square whole square plus 6d whole square plus 2 into d square into 6d, which is equals to d power 4 plus 6 is 36 d square plus 2 6 are 12 d cube. Right? Expansion d power 4 plus 36 d square plus 12 d cube by 11 square. 11 square is 11 into 11, 121. Minus expansion of d square plus 6d whole cube. Definitely here we are going to get higher derivatives from 3, 4 and all. Okay, we'll see. We know that a plus b whole cube equals to a cube plus b cube plus 3ab into a plus b. So let's utilize this formula to find expansion of d square plus 6d whole cube. D square plus 6d whole cube is d square whole cube plus 6d whole cube plus 3ab into a plus b, which gives d square whole cube is d power 6, right? 2 3s are 6 plus 6 cube, 6 6 are 36, 36 into 6, 216 into d cube plus 3 6 are 18 into d square into d is d cube into d square plus 6d. So we'll get d power 6 plus 216 d cube plus 18 d cube into d square is d power 5 plus 18 into 6 into 6 into d cube into d is d power 4. See, we got d cube, 4, 5, 6 all are higher derivatives. So we can neglect all the terms from here, okay, because from here we'll get completely higher derivatives, so we can neglect all the terms completely from here, okay. We'll just take the first 3 terms. In the third term also we have 2 higher derivatives which we'll neglect later in the problem, okay. Now coming to the problem, this becomes e power 3x by 11 into expansion of 1 plus x whole inverse is 1 minus x plus x square minus x cube plus so on into x square, okay. We just wrote this step. Now again this becomes e power 3x by 11 into 1 minus d square plus 6d by 11 plus d square plus 6d whole square by 11 minus d square plus 6d whole cube. Here you'll get 11 square, right? 11 square, 11 cube plus so on into x square, right? Now we'll neglect all the terms from here since d power k of x square is 0 from k equals to 3, right? 3, 4 and so on. So neglect d cube, d power 4 and so on. Higher derivatives. That is, neglect higher derivatives from d cube, d power 4 and so on. Okay. Then this becomes this is equals to e power 3x by 11 into 1 minus d square plus 6d by 11 plus expansion of d square plus 6d whole square into x square, right, which is equals to e power 3x by 11. Here we'll neglect d power 4 and d cube because the derivatives of d power 4 of d power 4 of x square is 0 and d cube of x square is 0, right? Higher derivatives, as I said you earlier, higher derivatives from d cube, d power 4 of x square will be neglected. So here we'll get 1 minus d square plus 6d by 11 plus 36d square by 121 into x square. Now this becomes e power 3x by 11 into 1 minus 1 by 11 into d square plus into minus 6 by 11 into d plus 36 by 11 d square into x square, which is equals to e power 3x by 11 into 1 minus 6 by 11 into d plus 36 by 11 minus 1 by 11 into d square. Okay. So 36 by 11 minus 1 by 11 is, here you'll get 121, right? It's not 11, 121. Now simplify 36 by 121 minus 1 by 11. So LCM of 121 and 11 is obviously 121. So in the numerator you'll get 36 minus 1 into 11 is 11, which is equals to 25 by 121. If you want, you can find the LCM of 11 and 121. 11 ones are 11 11s are, right? 11 into 11, 121 is LCM. In the first term, you're having the denominator of first term, you're having 121. So nothing should be multiplied to this 36. So we'll just write 36 as it is minus in the second term. In the denominator of the second term, you're having 11. So close one 11 and multiply this 11 to this 1. So we'll get 1 into 11, 11. 36 minus 11 is 25 by 121. This becomes e power 3x by 11 into 1 minus 6 by 11d plus 25 by 121 d square into x square. This becomes e power 3x by 11 into 1 into x square is x square minus 6 by 11 into derivative of x square plus 25 by 121 into d square of x square. We have the values of derivatives of x square, right? So let's place the values here. This becomes e power 3x by 11 into x square minus 6 by 11 into derivative of x square is 2x plus 25 by 121 into d square of x square is 2, which is equals to e power 3x by 11 into x square minus 6 2s are 12x by 11 plus 25 2s 50 by 121. Now find the LCM of 11 and 121. Will get 121 as your LCM. In the numerator will get 121 x square minus 12x into 11 plus 50. This is equals to e power 3x by 11 into 121 x square minus 12 into 11. 132 x plus 50 by 121. Now split the fraction as e power 3x by 11 into 1 by 121 into 121 x square minus 132x plus 50. This is equals to e power x into 1 is e power 3x. e power 3x into 1 is e power 3x. 11 into 121. 1331. 1331 into 121x square minus 132x plus 50. So the value for the first term is e power 3x by 131 into 121 x square minus 132x plus 50. Okay, the result obtained from the first term. Now let's find second term. This is also 1 by some function of d into e power x into v form. Now we can shift e power ax towards left by replacing d with d plus a, and later we'll operate a v with 1 by f of d plus a. So compare e power x with e power ax, and for a equals to 1 we'll find d plus a, which is equals to d plus 1. Shift e power x towards left by replacing d with d plus 1. You'll get d plus 1 whole square plus 2 into cos 2x, which is equals to e power x into 1 by d square plus 1 plus 2d plus 2 into cos 2x. This is equals to e power x into 1 by d square plus 2d plus 1 plus 2 is 3 into cos 2x. Right? Again, this of some 1 by function of d, some function of d into cos bx form. Right? We know that the known form 1 by f of d into cos ax we have already used. Already we have f of d square plus 2. So we have named this as g of d. Now let's find d square, which is given by minus of b square. For b equals to 2, we'll find my d square, which is equals to minus 4. Right? Now let's see what happens if we replace d square in the denominator. The denominator must be non-zero, because if we get the denominator 0, we'll get the term under brackets like this. Since 1 by 0 is undefined, so total term becomes undefined. So always remember that the denominator must be non-zero. Let's see what happens by replacing d square in the denominator. I'm taking the denominator part. Now I'll replace d square by minus 4. So I'll get 2d minus 1. 4 minus 4 plus 3 is minus 1, right? Which is non-zero. Since by replacing d square by minus 4 we got non-zero term, so we'll replace d square by minus 4 in the problem. Okay? Then we'll get e power x into 1 by, replace d square by minus 4, we'll get minus 4 plus 2d plus 3 into cos 2x, which is equals to e power x into 1 by 2d minus 1 into cos 2x. This is equals to e power x into 1 by 2d minus 1. Here in the denominator we are having 2d minus 1, right? So if we replace this minus with plus, we'll get 2d plus 1. Now multiply and divide 2d plus 1 to the fraction. Okay? Into cos 2x. Again, this becomes e power x into 1 into 2d plus 1 is 2d plus 1 by 2d minus 1 into 2d plus 1 is 2d plus 1 into 2d minus 1 into cos 2x. We can write this as e power x into 2d plus 1 by a plus b into a minus b is a square minus b square into cos 2x. This is equals to e power x into 2d plus 1 by 2d whole square is 4d square minus 1 into cos 2x. Again, d square appears in the denominator. So let's see what happens if we replace d square in the denominator. We'll get 4 into minus 4 minus 1 equals to minus 4 4s are 16, minus 1 is minus 17, non-zero. The denominator becomes non-zero by replacing d squared by minus 4. So let's replace d squared by minus 4. Then this becomes e power x into 2d plus 1 by 4 into minus 4 minus 1 into cos 2x. This is equals to e power x into 2d plus 1 by minus 4 minus 1 into cos 2x, which is equals to, 4 4s are 16, right? You'll get minus 16 minus 1. E power x into 2d plus 1 by minus 17 into cos 2x. Now this becomes e power x into, split this fraction as 1 by minus 17 into 2d plus 1 into cos 2x is equals to e power x into, we can write 1 by minus 17 as minus 1 by 17 into 2d cos 2x plus 1 into cos 2x is 2x. Is equals to minus e power x by 17 into 2 into, we know that d is a differential operator. Now we need to find derivative of 2x with respect to x in the next step, okay, plus cos 2x is equals to minus e power x by 17 into 2 into derivative of cos 2x is minus 2 sin 2x plus cos 2x. This becomes minus e power x by 17 into 2 into minus 2 is minus 4 sin 2x plus cos 2x. We can also write this as minus e power x by 17 into cos 2x minus 4 sin 2x. So this is the result obtained from the second term. Now coming to yp becomes, result obtained from the first term is e power 3x by 1331 into 121 x square minus 132x plus 50, and result obtained from the second term is minus e power x by 17 into cos 2x minus 4 sin 2x. Now let's write the general solution. The general solution is given by y equals to yc plus yp. We have yc c1 cos x root 2 plus c2 sin x root 2 plus yp e power 3x by 1331 into 121x square minus 132x plus 50 minus e power x by 17 into cos 2x minus 4 sin 2x. So this completes the problem. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.